Now let's take this theorem. If ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 represents a pair of lines, then prove that first bit ab plus 2fgh minus af square minus bg square minus ch square is equal to 0, and second bit we need to prove is h square is greater than or equal to ab, g square greater than or equal to ac, and f square greater than or equal to bc. So let us proceed this way. So let ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 represent the two lines. So the lines we will take it as L1x plus M1y plus N1 is equal to 0. Let's say this is equation number 1, and L2x plus M2y plus N2 is equal to 0, equation number 2. Therefore, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to L1x plus M1y plus N1 into L2x plus M2y plus N2. Now let us multiply these two brackets. So we get L1 L2 x square plus L1 M2 xy plus L1 N2 x plus L2 M1 xy plus M1 M2 y square plus M1 N2 y plus L2 N1 x plus M2 N1 y plus N1 N2. Now see, from these two we will take xy common. Okay, from these two we will take y common. Then from these two we will take x common. Okay, so that is equal to L1 L2 x square plus L1 M2 plus L2 M1 into xy plus M1 M2 y square plus L1 N2 plus L2 N1 into x plus M1 N2 plus M2 N1 into y plus N1 N2. Now if we compare the coefficients, comparing the coefficients, we get L1 L2 is equal to A, M1 M2 is equal to B, N1 N2 is equal to C, L1 M2 plus L2 M1 is equal to 2H, L1 N2 plus L2 N1 is equal to 2G, M1 N2 plus M2 N1 is equal to 2F. Now what we will do is, we will take 2H into 2G into 2F. So we will get L1 M2 plus L2 M1 into L1 N2 plus L2 N1 into M1 N2 plus M2 N1. So left hand side we will get 8 FGH is equal to, now if you multiply first two brackets, we will get L1 square M2 N2 plus L1 L2 M2 N1 plus L1 L2 M1 N2 plus L2 square M1 N1. This is by multiplying the first two brackets into M1 N2 plus M2 N1. Now we will multiply these two brackets again. So we will get L1 square M1 M2 N2 square plus L1 square M2 square N1 N2 plus L1 L2 M1 M2 N1 N2 plus L1 L2 M2 square N1 square plus L1 L2 M1 square N2 square plus L1 L2 M1 M2 N1 N2 plus L2 square M1 square N1 N2 plus L2 square M1 M2 N1 square. So now we will be replacing L1 L2 with A, M1 M2 with B and N1 N2 with C. So let's see how it will change. So that is equal to B L1 square N2 square plus C L1 square M2 square plus ABC plus A M2 square N2 square plus A M1 square N1 square plus ABC plus C L2 square M1 square plus B L2 square N1 square. Now if we take A common, from these two terms if we take A common, we will get M1 square N2 square plus M2 square N1 square. And then from the first and last term, if we take B common, we will get L1 square N2 square plus L2 square N1 square. And from the second and second last term, if we take C common, we will get L1 square M2 square plus L2 square M1 square. And finally, you have ABC plus ABC, that will become 2ABC. Now that is A into M1 square N1 square, we can write M1 N2 whole square plus M2 N1 whole square
Ma'am,
plus
if it,
B into
A common,
plus B into L1 and L1 N2 whole square plus L2 N1 whole square plus C into L1 M2 whole square plus L2 M1 whole square plus 2ABC. So that is A into, now again it is in the form A square plus B square. We can write it as A plus B whole square minus 2AB. So we will write M1 N2 plus M2 N1 whole square minus 2 M1 M2 N1 N2 plus B into same way L1 N2 plus L2 N1 whole square minus
it's
L1 L2 N1 N2 plus C into L1 M2 plus L2 M1 whole square minus 2 L1 L2 M1 M2 plus 2ABC. Now we are replacing the values. So A into 2F whole square minus 2BC plus B into 2G whole square minus 2AC plus C into 2H whole square minus 2AB plus 2ABC. So that is A into 4F square minus 2BC plus B into 4G square minus 2AC plus C into 4H square minus 2AB plus 2abc. So that is 4af square minus 2abc plus 4bg square minus 2abc plus 4ch square minus 2abc plus 2abc plus 2abc minus 2abc get cancelled. So you get 4af square plus 4bg square plus 4ch square minus 2abc will become minus 4abc. This is 8fgh. So if I take 4 throughout common, we get 2fgh is equal to af square plus bg square plus ch square minus abc. So if I bring all terms to one side, we will get ABC plus 2FGH minus AF square minus BG square minus CH square is 0. With this, the first bit is proved. Now let's prove the second bit. Second bit is comparatively easier. Okay, so second bit we will take h square minus AB. What is h value? L, L1 M2 plus L2 M1 by 2 whole square minus A is L1 L2 and B is M1 M2. So you will get L1 M2 plus L2 M1 whole square by 4 minus L1 L2 M1 M2. If I take LCM, L1 M2 plus L2 M1 whole square minus 4 L1 L2 M1 M2 whole divided by 4. Now A plus B whole square minus 4AB is the formula for A minus B whole square. So this we can write L1 M2 minus L2 M1 whole square by 4. So anything square of any number is positive, right? And a positive number divided by 4 is also positive. So this is greater than or equal to 0. So h square minus ab is greater than or equal to 0, which means h square is greater than or equal to ab. Now the other thing which is given in the second bit is g square minus ac. We have to do the same way. G is L1 N2 plus L2 N1 by 2 whole square minus L1 L2 N1 N2. Again the same way you open the brackets whole square by 4 minus L1 L2 N1 N2. You take the LCM now. L1 N2 plus L2 N1 whole square minus 4 L1 L2 N1 N2 whole divided by 4. This is L1 N2 minus L2 N1 whole square by 4. So square of any number is positive and a positive number divided by 4 is also positive. So this is greater than or equal to 0. Now the last bit which is given is f square minus bc. The same way m1 n2 plus m2 n1 by 2 whole square minus m1 m2 n1 n2. Take open the brackets m1 n2 plus m2 n1 whole square by 4 minus m1 m2 n1 n2. So that is m1 n2 plus m2 n1 whole square minus 4 m1 m2 n1 n2 by 4. So that will become m1 n2 minus m2 n1 whole square by 4. Again this is greater than or equal to 0. So here you can say that f square minus bc is greater than or equal to 0, which implies f square greater than or equal to bc. So all the three parts of the second bit are proved. Okay.
Okay, ma'am.
So take this theorem. If the equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 represents two parallel lines, then prove that number 1, h square is equal to ab, number 2, af square is equal to bg square, and number 3, distance between parallel lines is 2 root over g square minus ac by a into a plus b, or 2 root over f square minus bc by b into a plus b. So let's see how to start the proof. Let S is equal to 0 represent the lines. So here it is given that these two are parallel lines. So for parallel lines, x and y terms remain the same. The difference will come only by a constant. So Lx plus My plus N1 is 0. This is equation number 1. Lx plus My plus N2 is equal to 0. This is equation number 2. Therefore, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to lx plus my plus n1 into lx plus my plus n2. Now let us multiply them. So we get L square x square plus lmxy plus ln2x plus lmxy plus m square y square plus mn2y plus ln1x plus mn1y plus n1n2. Now again we take the similar terms common. So we get that is equal to L square x square plus there are two lmxy terms. So that will become 2 lmxy plus m square y square. If I take x common, we get ln2 plus ln1 into x. If I take y common, I will get mn2 plus mn1 into y plus n1 n2. Now comparing on both sides, we will get L square is equal to A, 2LM is equal to 2H, M square is equal to B. Then Ln1 plus Ln2 is 2G, right? Mn2 plus Mn1 is equal to 2F and N1 N2 is equal to C. So here 2 to cancel. So you get Lm is equal to H. Then from this equation, if I take L common, we get L into N1 plus N2 is equal to 2G. And from this, if I take M common, we get N1 plus N2 is equal to 2F. Now the first bit. First bit, they are asking us to prove that H square is equal to AB. So let us take H square first. H is LM, right? So LM whole square. That is L square M square. But L square is A and M square is B. That is equal to RHS. Therefore, H square is equal to AB. Now we shall prove the second bit. So for second bit, what do we have to prove here? AF square is equal to BG square. So let us consider 2G by 2F. So here 2 to cancel. G is L into N1 plus N2 by M into N1 plus N2. N1 plus N2 cancel. So you get G by F is equal to L by M. So if you cross multiply, you will get GM is equal to LF. So squaring on both sides, you will get g square m square is equal to L square f square. But we know that g square is b, sorry, m square is b. So this is bg square and L square is a. So this is af square, which implies af square is equal to bg square. Now we shall prove the third bit. What is the third bit? Distance between parallel lines. But from straight lines chapter, we know that distance between parallel lines is given by mod C1 minus C2 by root over A square plus B square. We have a formula for this. So now we will take C1, C2 as N1 minus N2 by A and B as L and M. So L square plus M square. Now again we know that A minus B can be written as root over A plus B whole square minus 4AB. So this I can write it as root over n1 plus n2 whole square minus 4n1 n2 by root over L square plus M square. Now if you see the last page, over here you see you have L into n1 plus n2 is equal to 2g. So I can write n1 plus n2 as 2g by L, right?
Yes, ma'am.
So we can write this as 2g by L whole square minus 4n1 n2 is c by root over a plus b. The remaining part I am continuing here. So that is root over 4g square by L square minus 4c by a plus b I will write. Because for numerator and denominator both you have square root. So that is root over 4g square minus 4L square c by L square into a plus b. But we know that L square is a, and if I take 4 common from the numerator, I will get 2 outside, root over g square minus L square is a. So it will become AC, and denominator also L square we can replace with a. So that is a into a plus b. So first part of the distance between parallel lines is proved. Now we shall prove the second part of the distance between parallel lines. So if you see the previous page over here, after comparing, we got this one you see now. M into N1 plus N2 is equal to 2F. So from here, can I write N1 plus N2 as 2F by M? So the same way I am doing it. So again, distance between parallel lines. Distance between parallel lines formula is mod C1 minus C2 by root A square plus B square. So that I am writing it as mod N1 minus N2 by root L square plus M square. Now again N1 minus N2 I can write it as root over N1 plus N2 whole square minus 4N1 N2 by root over L square plus M square. Now in the place of N1 plus N2 I can write 2F by M. 2F by M whole square minus 4n1 n2 is c by root over a plus b. Now again I will continue it on the left hand side. So we will get under root 4f square by m square minus 4c by a plus b. Now if I take LCM, 4f square minus 4m square c by m square into a plus b. Now if I take 4 common from the numerator and bring it outside the square root, it will become 2. And now again I am replacing m square with b. So this is bc by b into a plus b. Hence proved.